everybody, welcome to IB Math. So let's talk about this huge stack of papers. Okay, I'm going to assume that you do not have the wherewithal to print 95 sheets of paper. That's perfectly okay. Remember, you can just work the problems on a sheet of notebook paper and that works great. So let's go through just a few of these. So I ask you to please try and do 5. Maybe 6 or 7, but not any more than that. Remember that you gotta pace yourself. You're only supposed to be doing about 120 minutes, although I would recommend doing a little bit more since you're an IB. Oh, and don't forget, paper, try and get it to me by this Friday. Okay, so let's walk through this problem, make sure you're okay with it. So first of all, this one was on our last quiz, so I wanna make sure you were okay with it. I pulled it off of an old exam. Now, if you look up here in this upper corner, that tells you the year that this exam was taken, and it tells you, say May 2016, and then this tells you which test it was and which time zone it was, if you want to look up answers online. Okay, so let's start with our first problem here. The first one I wanted you to take a look at again was this one. So if I'm doing part A on this one, the first thing I'm going to do is I'm going to write down an equation for both of these things. So it looks like it talks about surface area. Okay, there are 2 sides on either end that are squares. So it'd be 2x squared plus, because the top is open, there will be 3 of these rectangular sides. Okay, you also can write a volume equation. So volume is going to be x times y, so x squared y. Now they tell you right up here at the beginning that the volume is 36, which will allow you to write the following. So hopefully that is okay. Then I'm going to take this number, the one that's right here, and I'm going to put it right over into my surface area problem. And I'm going to simplify. So that will give me 2x squared plus, remember calculator's always handy in case you need it, 108 over x. Okay. So it asked me to do that. That is my step A. Now, let's talk step B. Step B, they would like me to find what they're calling capital A. We can just call it surface area. And they'd like me to find the derivative. So I'm going to take the 2 down front, giving me a 4x to the first power. Now, the piece that's over here, I'm going to I'm going to write it over here. That is 108 x to the negative 1 power. So when I bring the negative 1 down front and then subtract 1 from it, I'm going to end up with negative 108 over x squared. Okay, so that's how I get that derivative. Now it says, given that the surface area is minimized. Okay, so when you minimize surface area, that means you're going to set the derivative equal to 0 and solve it. So move the 108 over to the other side with addition and subtraction. Multiply the x squared. Divide by 4. So that means x is equal to 3. So I know now x is equal to 3, so I'm going to take that over. Oh, by the way, I'm working on part C here. I'm going to take that over and find out what y is. So I know that 36 divided by 3 squared equals y. So it looks like 4 is going to be equal to y. Okay, so I've got 4 equal to y. So at this point, I can find out what the actual surface area is, so I can figure out how much paint I'm going to need. So going to part D, I need to know the actual surface area of my object. So that's going to be 2 times 3 squared plus 3 times 3 times 4. Okay, so going to my calculator, that will be 2 times 9 plus 9 times 4, so 54. And that's meters squared. Now, let's talk about this for just a moment. Now, each tin of paint covers 10 meters squared. I am not able to buy part of a container of paint, so I have to buy the whole thing, so that means I will need 6 tins of paint at a cost of $20 a piece. So it is going to cost me $120 to paint the outside. All right, so hopefully that one went okay for you. All right, I'm going to skip ahead just a little bit. Again, you can kind of do these in any order you want them to be, any of them at all. Let's take a look at this one. Okay, this is from May 2015. It's the first page of the exam, and it's in time zone 1 if you're trying to look it up. So taking a look at this function, it says that k is a constant. Again, I used this one on the last test as well. So first thing I'm going to do is I am going to find out looks like these, let me grab some glasses real fast just to make sure I can see exactly how many little dashes there are. Okay, it says it would like the second derivative for a. So let's go ahead and let's find that second derivative. So if I'm finding that, I'll need 6x minus 2k. That'll be that derivative. All right, so second derivative says that the graph has an inflection point at x equals 1. So that means that I'm going to be doing a little bit of substitution here. So I'll do f double prime of 1 equals 6 times 1 minus 2k. And since that's an inflection point, that means that this function should be equal to 0 at the same time. So that gives me 6 minus 2k equals 0. So negative 2k equals negative 6. So k equals 3. That means I now know that my function, by the way, I just did part B, I now know that my original function, well, the function they were given, which is the first derivative of x, is going to be equal to 3x squared minus 6x minus 9. Okay, so that's what I'm able to get now that I know k is 3. Okay, so now I would like to know what is the value of this function at negative 2. Okay, so that's pretty straightforward. That's just a substitution kind of a thing. Let's say type it in your calculator. Now, if this were in the non-calculator section, I would do 3 times 4, 12, plus 12 minus 9. Okay, so let's see, that's 3. So that's 15. Okay, so hopefully that one's okay. Next thing it says is, it says find the equation of the tangent line. Okay, so just to remind you, when you're doing this, this tells you the slope or the gradient of your tangent line, and this is the slope or the gradient of my tangent line at this point. So that is the slope at x equals negative 2. So then when I go to part D and I want to write the equation on that line, I will do y minus 1 equals, and this is going to be the tangent, so 15 x minus negative 2. Okay, so y minus 1 equals 15 x. And let's see here, and then I've got that distributed over there, so plus 30. So y equals 15x plus 31. Okay. Then the last one says, given that the equation equals 0, so when I solve it here, we get 0 if you do this. So let's take a look at E. So f prime of -1 equals 0. Okay, so that's going to be an intersection point. Explain why the graph has a local maximum at this point. So the best way to do that is with a line. So let's see here, I'm going to say x equals -1, and I'm going to check the slope for each side. So I'm going to come over here and I'm going to do f prime of -2 and f prime of 0. Okay, so I'm going to put those values in. Now at this spot, I know that, because I've already calculated it right here, so I'm going to bring it down from over here. That is a positive value. Now if I put in 0 for the same problem, I get a negative over here, which means that if you look at the slope, you are going up and then you're going down, which means right at this point has to be a maximum. So that's how they walk through that process. Okay. Ooh, here's another nice one. This is number 7. So this was 15, so 2015, test number 1, time zone 1, if you're looking for the answer. And it says on this one that you're supposed to find the value of B. Okay, so here's what I know. I know that if I go from 3 pi over 2 to B of my function, which is cosine of x, that should give me the area under the curve. Okay, so make sure you look at your integration formula, and that's going to tell you that this is sine of x going from B to 3 pi over 2. All right, so let's see what we end up equal to. So we'll have sine of B minus sine of 3 pi over 2. And that is supposed to be equal to 1 minus square root of 3 over 2. All right, so let's see if we can figure this out. So if I take a look at this and I'm thinking about my unit circle, which I'm going to draw right over here, that's 1 pi over 2, that's 2 pi over 2, and that's 3 pi over 2. So down here, the value of sine, which is the y value, is -1. So I'm going to have sine of B minus -1 equals 1 minus the square root of 3 over 2. So that means that I have sine of B equal to negative square root of 3 over 2. So that means B is going to be equal to sine inverse of negative square root of 3 over 2. So what you're asking yourself is, where on the unit circle does sine have a value of square root of 3 over 2? So if I go over here on my unit circle and I come over here to 60 degrees, my coordinates here are going to be 1/2 comma square root of 3 over 2. So that's a good guess, but it's not the right guess. So 60 degrees, not the best choice. I come over here to 120 degrees. At this coordinate, I have -1/2 comma positive square root of 3 over 2. Okay. Then I'm going to come down here to the bottom. So if I add another few degrees on there, another 60 or so. Oh, I forgot this one over here. If I add another 60, I'll be at 180. So let's see here, 180, that's not going to be right. That's -1 comma 0. If I come on down here, let's see, that was 180, so this will be 240. I get -1/2 comma negative square root of 3 over 2. And then if I come over here to this side, let's see here, this one, that is going to be, add another 60 on, 300 degrees, and that is going to be 1/2 comma negative square root of 3 over 2. Okay, So to prevent there from being multiple answers, you're going to need to use the principal values. So the principal values for sine, lock it in between 0 and, well, lock it in between pi over 2 and 3 of pi over 2. But basically you're talking about this side of the picture. So in that case, I would say that B is either going to be equal to negative 60 degrees, in other words, 60 degrees from 0 down this way, or I might say that it is negative pi over 3, and that's going to be my value. Depending on whether you want to do radians or degrees, it is not picky about which one you pick. You just need to pick one or the other. All right, so that's a few questions. I'm going to tell you to keep working on the questions as you go along. This one was also on our last test in case you want to take a look at that one. I've just been working through them slowly but surely, and they're not too bad. I mean, there's a couple that are a little bit more challenging in here, but you should be able to do just about everything in here. I do recommend that at this time that you skip this one. So that is the November 2014 SP1 T time zone 0. So I would skip that one for right now because that's really more of a vector problem, and we'll come back to that one when we do vectors. Okay, so tomorrow I'll post some more solutions. If you have specific ones you want me to talk you through, just text me what problem number it is. Make sure you tell me the year that it's occurring on, and if it's an SP1 or an SP2, and if it's time zone 1 or time zone 2. And I will work through problems with you. Again, focus on just trying to do a few of these a day. Make sure that you're spending a total of 120 minutes for the week on calculus problems. All right, so that's kind of it for right now, and I will be back tomorrow. My cute little pork says, hey everyone, hope you're doing well today. Have a good afternoon.